According to Wikipedia, about 10% of the world population is left-handed. Now, an institution is hosting a conference with 370 participants, but they have only 48 left-handed desk chairs. So they are worried if what will happen if more than 48 of those 370 participants are left-handed. So one way we can handle this question is that we can take or assume that the percentage of left-handed people in the population is 0.1 and 370 participants are a simple random sample from the population. Okay. Now we can take many samples of size 370 from this population and see that how many of them do have more than 48 left-handed people. Okay, so what we will do is that we are just going to go to this easily available tool in Excel, which is called random number generation, and say we want how many? 370, a sample of that size, and let's write that down, 370, and we want say 1000 samples of size 370, and this Bernoulli is for proportions. That is what we are going to do is that we are going to tell it that the attribute of our interest has proportion 0.1 in the population, and let's put the results in A2. Okay, so if we do that, then what it will do is that it will go ahead and take simple random samples of size 370. Of course, I have given it a bigger number generation, so it's taking a little longer. So here are the samples, and each row has 370 values. Now when we see 0, that means that the person is not left-handed, and when we see 1, that means the person is left-handed. So you can see they found a left-handed person. Then we have not left-handed. So if we go to the end here and we take the mean of all these values, okay, let me enlarge the font here. Okay, so if we take the mean, all right, so here I can just go to the function and take the average. So what we got is that about 11.6% of 370 people in this sample are left-handed, or in other words, let's calculate quickly, 0.116216 times 370 is how many? About 43. So they don't have to worry about, in this case, here's like 0.091892. So that will be less than 43. All right. Then here the proportion is 0.1118. So let's see what that will be. 0.118919. Of course, it'll be more than 43 that we had before. So, you know, that is 44. We still have 48 chairs. So we can do this. That is, if you simply double click here, then it will give you the percentage of left-handed people in each and every sample. All right. So let's just go ahead and make a plot of it and see that how many samples have how many samples of size more than, how many samples of size 370 have more than 48 left-handed people in there. And we should also quickly note that 48 over or 48 out of 370 as proportion is going to be about how much? 0.1297, or say approximately 0.13. So what we are worried about is that the probability or the situation in which the proportion of left-handed in this, in among these participants would be more than 0.13. Okay. So let us just now take up this stat key, this free online software, because in Excel we will have to do more work. So I'm going to do this. I'm going to copy our values from Excel. Okay, so let me do that. All right, and then I will just paste those in this stat key. So I'll say edit data, and we would just do this, so that here we go, that we have all those values. So let's see what happens. So here is 0.13. All right, and if you count these guys, then I mean, this is of course 0.13 or less. So there are 4 values here, then 4 plus 8 is like 12, 13, 16, 4, 20, 22. So what we have is that chances are like 22 out of 1,000, that is 0.022, that they will have more than 48 left-handed people in that set of participants. Okay. Now, of course, there is another way. If you know how to compute binomial probabilities, you can just go ahead and take what we would do is that we will go to binomial cumulative function. Okay. And we are looking at 370 participants. The probability that a participant being left-handed is 0.1, and first it would calculate for us that what is the probability that 48 or less people will be left-handed. So it computed that probability to be 0.973, and if I subtract it from 1, that will be 0.027. So of course it differs quite a bit, the theoretical situation from the situation that we got via simulation. All right, but anyway, this is the precise procedure, but the scenarios may not always be precise. And anyways, this computation that we did by simulation, it gave us a probability that's not really that far off from the theoretical probability, and especially in this particular scenario. All right, those kinds of left-handed desk chair would not be that expensive to get if they are really worried about this much difference. Okay.